Good day, everyone. We are now on the next topic of our third module. So, still under the time value of money, so under the interest. So, if you would recall, we have discussed the first type of interest, which is the simple interest. Today, we will be discussing about the other type of interest, no, which is the compound interest. Unlike simple interest, which is made at a single time only, compound interest is different. No? Commonly, compounding are used by lending institutions, no, used by banks and many other institutions or establishments that uses money. So there were only a few who use simple interest, because in the side of lender, the uh, the amount or the gain that the profit that they can get from simple interest is much lower compared to compound interest, something like that. Now, before we will discuss compound interest, now we will discuss first cash flow diagram. This will be useful when we will discuss the next topics, especially on annuity. So now in the cash flow diagram, we actually have uh, parts of it. We have to take note of these parts. We have an arrow up. Now when we say arrow up, that is a receipt or a cash inflow. So for example, if I will be receiving a money, so if I would draw a cash flow diagram, that would be in arrow up. That would be drawn using an arrow up. If you would be spending money, so you will use arrow down. So that is called disbursement, or a negative cash flow or an outflow. So if you are in the side of the lender, when you lend a money, so that's arrow down. No, that's a disbursement. But when the person who borrowed an amount paid you, so that's a receipt for you. Now, we have two viewpoints. One is for the lender, as what I have told you earlier. So we have here arrow down, meaning the person or the lender lended money to the borrower. Then after some time, the borrower will pay. So in the lender's viewpoint, so that's an inflow. That would be the opposite in the borrower's viewpoint. Now the cash flow diagram in the borrower's viewpoint. In the next problems, you have to analyze which viewpoint will be used. Will it be for the lender or the borrower? Now you have to check the statements of the problem. So here are the definition of a compound interest. It's actually an interest on top of interest, for a certain number of periods. So instead, say for example, in the simple interest, you borrow an amount and you have to pay it after a year. Then you will be paying 20% simple interest. So you just have to multiply the borrowed amount by 20%. So that would be the interest. However, for compound interest, we have the term compounding. For example, if you borrow an amount today and you will pay it after a year, and the lender would tell you that it will be compounding. No, it will be compounded, say monthly. That would mean that every month there will be an interest. An interest that will be placed on your borrowed amount. So in the first month you have an interest. In the second month another interest will be placed. Third until the last month. So which means the lender would have larger profit compared to simple interest. So say for example, if you borrow 10,000 with a simple interest of 10%, then after a year you will be paying 11,000. However, if you use compound interest, that means your 11,000 10,000 rather, which has a 10% interest compounded monthly, so which means every month there will be a 10% interest that will be placed on the 10,000 borrowed. So imagine how much total interest will be gained out from the borrowed amount. Now here is again we'll have this in the borrower's viewpoint. So this is our cash flow diagram for compound interest. Now in these periods here, we call them number of compounding periods. So there will be an interest placed. Then that will be the time the accumulated amount will be paid. So say for example, so there, this is a table to show you how compound interest works. So say for example you have n compound interest periods. It can be number of years or it can be number of months, depending on the problem. So at the beginning, when you borrowed an amount, so that's P, so we know that it will earn an interest. Okay, so that would be P times I. So this is our I. Okay, let's use a pen. Now this is actually our I. So I. Now, supposedly I is equal to P times I times N, but since we calculated it per, say per year or per period, we'll consider that N is 1. Here 2N would be 1. So we'll now only have P times I. Then after the end of each period, we'll have an F, non-accumulated amount. So you have P plus PI or this one. Then in compound interest, what would be the next question will be, what will be the amount here at the beginning of the second period? So it will not be P, but rather the F in the previous period. And that is this one. Okay, since N is equal to 1, so I times 1 is just I. So that is why we have this. Now take note that this is our F of the previous period. So the F of the previous period will be the principal amount, and this amount will then be again placed with an interest, an interest rate, until it would be accumulated. So that is why in some problems the F here is called the accumulated amount, because as the number of periods pass, it will have an accumulation. So after a certain period, certain number of periods, so our principal, our borrowed amount will become an F, and that is calculated using P times the quantity of 1 plus I, quantity raised to power N. So this is how compounding works. So our formula again is this one. Next, now that F is again the accumulated amount or the compound amount, which can also be termed as, commonly known as the future worth of a principal or the present worth, the present amount. Again, the equations are here. So F is equal to P times the quantity of 1 plus I, quantity raised to power N. This factor here, this quantity here, is termed as the single payment compound amount factor. We can also use this notation. So most of the books will use this notation, that F of P, or F given P at I% rate in N interest periods. So that is read as F given P at I% in N interest periods. Then the P will be the present worth. We'll just have to use cross multiplication methods so that we can get the value of P using our formula F is equal to P times the quantity of 1 plus I quantity raised to power n. So since we are looking for P, so we have to cross multiply this one, or in other words, we can divide both sides by the reciprocal of the term that we want to eliminate in this side, no, in the right side. So we'll have to divide all the sides of the equation by the quantity of 1 plus I quantity raised to power n. Now then, we will then get F over the quantity of 1 plus I quantity raised to power n is equal to P. So by laws of exponent, no, a uh, when a term is in the denominator and you want to bring it to the numerator, then that would mean we will change the sign of the exponent, and that will become negative. So that is why we have this equation for the present worth. Now this quantity here is called the single payment present worth factor. If you compare it to previous, that is the single payment compound amount factor, compound worth factor. We can also rewrite this in this notation: P given F, meaning the given value, this is the unknown value, this is the given value at I interest rate in n compounding periods, or n periods. Okay, now the one that we're talking is interest. Take note that it's a capital letter I, but when we use a small letter I, that is the rate of interest. The rate of interest has two types. No? In compounding, we will not directly use I. Okay, we will not directly use I, but we will use either nominal rate of interest and effective rate of interest. Nominal rate of interest is denoted by the variable lowercase r, while the effective rate of interest, or the actual or exact interest, is denoted by ER. In most of the equations, we will be using R. Okay, since I, the rate of interest, is actually equal to the nominal rate of interest divided by the number of compounding periods. When I say number of compounding periods, if you would recall the example earlier, this is the number of the times where an interest will be placed in a single year. So say for example, if you would recall the previous in what I have said earlier, that if you borrow an amount and an amount to be paid in 1 year, and an interest will be placed every month, so that monthly placing of interest is actually the number of compounding periods in a single year. So if you would place an interest every month, so in a year you have 12 months, so your M will be equal to 12. So it depends on the problem. There will be times that compounding is done quarterly. So meaning in a single year, since you have quarter, there are 4 quarters in a year, which means you have to every 3 months there will be an interest placed on the amount borrowed in a single year. So your M would be equal to 4. If we also have the term semi-annually, which means every 6 months, so twice a year, an interest will be placed on the borrowed amount. So again, the nominal rate of interest is equal to R over M, where R represents the nominal rate of interest and M is the number of compounding periods in a single year, in 1 year. So you have to remember the terms quarterly, semi-annually, per annum, monthly. Now that would indicate the number of compounding periods. Next is the effective rate, or the actual rate. Now, it is the exact rate of interest for a single year. So if you want to convert, or if you want to get the rate of interest in 1 year when dealing with compound interest, so we will use this equation. The effective rate of interest is equal to the quantity of 1 plus I, quantity raised to power m minus 1. Take note of this I. Now, if it's not given, of course, the nominal rate of interest will be given. Now, so we will be then using R over M, which means that when the nominal rate of interest is given, our equation will become ER is equal to the quantity of 1 plus R over M, quantity raised to power m minus 1. Again, you have to take note that this is the exact rate for a single year, for 1 year. That's the effective rate of interest. If compounding is per annum, so when I say if compounding is per annum, annum is year, no, annum is equivalent to year, they're both the same, no? Which means your m is equal to 1. Okay, when your m is equal to 1, if you would substitute the values here, when m is equal to 1, so that's 1, then 1, you will have r, no, then you have 1 plus r minus 1, so it will be eliminated, 1 will be eliminated, so what will left is r. Now, since I is equal to r over m, and your denominator is equal to 1, if the compounding is per annum, then your ER, your R, and your I are all equal. That's again when compounding is per year, meaning placing an interest is done in every year on a single year. So instead of using this equation, the first equation that we have discussed, we will replace I. Remember that I is equal to R over M. Now, if you would recall the ER equation, now as you can see here, you have an M placed at the exponent. So that is actually the number of the number of compounding periods. Now, when M is now involved, R and M are now involved, we will also change the exponent to M N. So which means our new equation when dealing with compound interest is F, the future worth or accumulated amount, is equal to P times the quantity of 1 plus R over M, quantity raised to power of Mn. So this is the number of compounding periods. This is the number of year. Now, because there will be times that an amount will be paid after 10 years. However, every year, an interest will be placed say for example, every 2 months. Which means in 1 year, six interests will be placed for your borrowed amount, and the total accumulated amount will be paid at the end of say 10 years. So that is why we use this equation. We also have a case wherein compounding is continuous. When we say compounding is continuous, approximately it's done every moment. Say it can be per hour, per minute. That's continuous compounding. So an infinite number of compounding in a single year. So in 1 year, a lot of interest are placed in a single year. So if that's compounding, if this is actually derived from the formula, the original formula, that is 1 plus P rather is equal to the quantity of 1 plus R over M, quantity raised to power M times N, where M approaches infinity. So this is called continuous compounding. So when m approaches infinity, so based on some derivations, our f is equal to p times the exponential value of r n. Take note, this is a constant value. In your calculator, you can you will see the value of e there. You have an e there in your calculator. So if you would be using this equation, that would be p. Say for example, p is 10,000, r is equal to say 0.1, n is equal to 5. So that would be 10,000 e to the 0.1 times 5. So that's p per. No, that is when compounding is continuous. So let's have this example. Now, if 1 peso is invested at a nominal rate of 15% compounded quarterly, after 1 year it will become 1.16 pesos. Now, how did we solve it? Check first the given values. 1 peso is invested, which means this is our present worth. Now, at a nominal rate, now take note of this. There will be times that this term is not mentioned, no, at a rate lang ang ibutang, but you have to take note that when there is compounding, automatically that is r, the nominal rate of interest, which is 15%. So if you will divide 15% by 100, that would result to 0.15. Now when, and then it's compounded quarterly. So since it's quarter, that means quarter is 1/4, no? Which means in a year there will be 4 compoundings. No? In 1 year, kaupat siya, 4, it will be the number of interest that will be placed, no, the number of times the interest will be placed is 4 after 1 year. Now we can use our equation, but I will show you both using the equation and using the previous table, no, that just to simulate what happens when we place compounding. So here is a tabular. This is the longer method, no, wherein we will be viewing what happens after compounding. So these are the number of periods. Now since we have 4 compoundings in 1 year, so that is why we have 4 periods. Now if in case the problem would state that quarterly after 2 years, so which means the number of compounding periods will also increase. And how will we calculate that? That would be m times n. So the number of compounding period, the number of interest periods rather, is equal to the number of compounding times the number of years. Now this is, say when n is equal to 2, then we'll have 4 times 2 is equal to 8. So it will be until 8 interest periods. But in this problem, we only have after 1 year. So as you can see, this is the present worth, the borrowed amount at the beginning of the period. This is the interest. Now, if you would recall, that is P times I times N. But again, N here is considered to be equal to 1. So since we're calculating every period, that's equal to 1. So we'll only have P times the rate of interest. Then, so after a single compounding, now it becomes 1.037500. Then second, approximately, although here it's rounded to 4, but actually I used the exact value so that the rounding error will be much less. No, we have an approximate, an accurate value. So I would suggest that you round numbers only if that is your final answer. So which means if this is not my final answer, my final answer, the last answer, my final answer will be then rounded, no, to the nearest hundreds. So that's 1.16. If you will use the formula, so it should be equal to using tabular. No, this is using the formula. You have f is equal to p times the quantity of 1 plus r over m quantity raised to power m times n. So substitute all the known values p, r, and m. So again, I is equal to r over m. Okay, take note of that, r over m. So this is your I. Then your n is equal to 1. So since in the problem it's only 1 here, so n is equal to 1. So it would result to 1.1586, or again, that's equal to 1 point approximately, so since we round it, 1.16 pesos. So this is how compound interest works. So our final another question is that we have to get the actual or the effective rate of interest. Now since we're calculating just 1 year, so actually this is the exact interest, or the effective interest in 1 year. So when you convert that to percentage, that's 15.86%. Remember that 0.1586 is not equal to 15.86%. We just converted 0.1586 to percentage by multiplying it, this one, by 100%. Now we have other problems here. The amount of 20,000 was deposited in a bank, earning interest of 6.5% per annum. Determine the total amount at the end of 7 years if the principal and the interest were not withdrawn during this period. So we have a given value, we have a given answer na, and we have the next problem, the nominal rate of interest. In the next slides, we'll be showing the solutions using the formulas. Number 4 will be your engage activity. Now, number 4 will be your engage activity. Answers will be shown in the slides once it's uploaded, but you will be the one showing the solution. Okay, let's have these. Okay. So this is the problem here. Now the question is again to find the nominal rate of interest if converted quarterly. So you take note that we are asked to find the nominal rate of interest, and that's R, converted quarterly. Quarterly means M, no, and it could be used instead of 12% compounded monthly. So take note of the problem. If you would analyze the problem, you have an R at a certain M. However, there's also another R at another M, which is equal to 12. Then another question is that we have to get the effective rate, which means we have two unknown values here, an R and an effective rate. No, remember that effective rate is in terms of years, so that will be our B. Now we have two unknown values. Now if you would recall, okay, anyways, these are the given values. You have an R, which is converted quarterly, that is our unknown. So we will use the notations here. Since monthly we have 12 compounding, quarterly 4 compounding, so we will use these values para not be confused. Again, so though you can variables rather, though you can use other variables, but for me it would be easier for me to identify, to understand what I'm referring to. Okay, now if you would recall our formula, F is equal to P times the quantity of 1 plus R over M, quantity raised to power M and N. If you would check these values based on the given. We have n, m, r. However, we don't have p. Also, we don't have f. So this would mean we cannot use this equation. Now, if you would recall, we still have another equation, which is ER, the effective rate, no, the exact rate in 1 year. That is 1 plus R over M, quantity raised to power M minus 1. So, which means if we can get now the effective rate of this R at a certain compounding, and also the effective rate of this R again at a certain compounding, so that we might be able to solve the problem. Now, checking, we have these values. Now, we only have an ER which is unknown. We have here an R and an M. Now, we can actually equate these two ERs. The ER for compounding monthly, now using this equation, the quantity of 1 plus R sub 12 over M sub 12. So again, I use ER sub 12, which means we will find an effective rate at a nominal rate compounded monthly. So we have 12 compoundings in a single year since the compounding is monthly. Then remember that ER is the exact rate, the exact rate in 1 year. So which means if we will get the ER of this one, the ER of R compounded quarterly must be equal to the ER of 12% compounded monthly, and that is an ER compounded quarterly will then be equal to 1 plus R to the 4th over M sub 4 rather, raised to power M sub 4 minus 1. Again, remember that we are referring to an exact rate in a single year. Then we have these known values here. Therefore, we can equate these two. Okay. So if we will equate these two, that will be ER sub 12 is equal to ER sub 4, meaning the exact rate or the effective rate when using a monthly compounding should be equal to the effective rate when using quarterly compounding. And take note again that we are looking for R, so that we have to equate both of these in order for us to determine R. So equating both, so ER sub 12 is equal to this term here, this group here, and ER sub 4 is equal to this one. We will substitute the values of ER sub 12 and ER sub 4. Then we will derive a formula for R sub 4, and that is M sub 4, this one. Then again, we are looking for R sub 4. We know these values here. Okay, so the next step, so our goal here is again to let R sub 4 be left on one side, and all other variables or other values will be placed on the other side, so that we can get the value of R sub 4. Okay, the next thing to do, we will then, so what we'll do, we will then transpose -1 to the other side. Okay, so that we can remove 1 here. Then we'll have the quantity of 1 plus R sub 12 over M sub 12 quantity raised to power M sub 2 minus 1 plus 1. Take note that when you transpose, it will be the sign will become positive. The sign will change. So what would be left on the other side is now that the term which has R sub 4. And take note, -1 plus 1 is equal to 0. Then after, we will get the M sub 4 root, para si MR4 na lang yung mabilin. So get the M sub 4 root of one side and also on the other side. Okay, you take note, no, we can eliminate then, no, the m4th root of a term raised to power m sub 4. So we can remove that, and rewriting, we have 1 plus uh, 1 plus the quantity of 1 plus r over m. Now take note of this, m sub 12 is the exponent while the radical is in the m sub 4. So how will we rewrite that one? That is m sub 12 over m sub 4. If you will recall the laws of exponent, no, an an root of a variable, say x raised to power b, can be rewritten as x raised to b over a. So that is why we have this term here. That is equal to the quantity of 1 plus r sub 4 over m sub 4. So as you can see here, we can now let r sub 4 be placed on or left on one side. So I will just forward this video here. Okay. By using transposition methods and cross multiplication methods, now we have transposed 1. Since we can remove the quantity here, no, we can already remove this one since we have eliminated the exponent. So transpose 1, so it will become -1. Then cross multiply m4. So that means all of the terms here on the other side will be multiplied by m4. So that is why we have this formula here. No, you have the m sub 4 times the quantity of 1 plus r sub 12 or m sub 12 quantity raised to power m sub 12 over 4 minus 1 is equal to r sub 4. Then we will now substitute the values after rewriting. So if we will rewrite this, the one side, no, by common or standard notation, the variable should be placed on the left side, and all that which have the exact values of variables which have values, equivalent values, will place on the right side. So we'll now then substitute values. Oh, what happened? Oh, sorry for that. Okay, we'll then we'll then substitute the values, okay, of our variables, no, since we know the values of our variables. Then we'll have r sub 4 is equal to m sub 4, and that is, if you would recall the part here, m sub 4 is equal to 4. It would be easier for me to know because of this notation here. So that is 1 plus r sub 12, which is 0.12, divided by m sub 12, that is 12, quantity raised to power, and 12 over 4 minus 1. Oh, so by the way, do not forget the quantity. Then use your calculator. We should be able to get you can, if you have this equation, you can directly use your calculator, but to simplify it further, we'll have this 1 plus 0.12 over 12. I think it will be much easier if we will divide 12 by 4, if it's since it's divisible, so that will be equal to 3. So we can now calculate, and the result is 0.12 0.1212. It will be better if you get the next two decimals, so that when rounding, since we will round it to 4 places, decimal places, since when you convert it to percentage, that will be 12.12%. So that's our first variable, no, for our answer to letter A. R4 is approximately equal to 0.1212, 12.12%. The next question was to determine ER, the effective rate. Now again, take note that ER sub 12 and ER sub 4 are equal. So since based on the definition, ER is the exact rate of interest or the effective rate of interest in a single year. When you convert all of the compoundings in 1 year, you will get the ER. So recall the equation or the formula. Now we can use, I would suggest that you would use ER sub 12 since this contains all the given values. Now the ER sub 4 contains the calculated value. So you might have some difference in the decimal values. No, and it would be safer for me if I will use ER sub 12. However, I will show you later that the two would have the same values. Now let's substituting the values, we will get this 0.12 6825, or approximately that's 0.1268. Now since the fifth value is 2, so when we round it off, this would just be equal to 0.1268. Now let's check now if it would give the exact values. Now if you would use your calculator, if you would use your calculators, you might have you might get a different value, no, especially on the last part here, but I will use the exact values instead so that I can have the same results. Now that should be equal to 0.1268. Check for yourself if these the solutions are correct, no, or if we can get the same answers. So our answers are R sub 4, or the nominal rate when compounded quarterly is equal to 0.1212, and the effective rate is 0.1268. So that's the second example. Next, we have sorry for this. This is not the description. So this is now this is the question here. The amount of 20,000 was deposited in a bank, earning an interest of 6.5% per annum. So we have to determine the total amount at the end of 7 years if the principal interest were not withdrawn during this period. So the amount of now take note, you have 20,000 here, which is what deposited, so this will be our P. Then we have an interest. Take note again, it's not stated what type of interest is this one. No, but when it's compounded, automatic this is R. However, based on the problem, it's per annum. Now our M is equal to 1. So if you would recall the previous definition that when compounding is done every year, so ER, I, and R will be just equal. But we'll still use R now just to show you how it works. So recall the equation. F is equal to P times the quantity of 1 plus R over M, quantity raised to power M, N. We know all these values. We have P, we have R, we have M, we also have N. So just substitute all the values of our variables, known variables. So that's 20,000 multiplied by the quantity of 1 plus R, which is 0.065. Do not use the value which is the percentage. No, mathematically speaking, we cannot multiply that with these. And M is equal to 1 since it's done yearly, so that's 1 times 7, no? Wherein we'll be paying it at the end of 7 years. So using our calculators, you will get an F. Okay, we should be able to get an F that's approximately equal to 31,000 31,079.73 pesos. Okay, imagine after 7 years, now using 6.5% interest, we'll have 31,079.73. Okay, that would be all. Now the next, the answers to question number 4 will be uploaded, using the PDF file. So you have to um, check them. Okay. Thank you. This will be all, and have a good day.